Welcome to another video for CS 1064. We're going to do some more work with object-oriented programming. We last week developed a card class and a deck of cards class to represent those items. For your reading, you had as well as that, you had a bank account class example, and we're going to build off that bank account class today for our discussion of inheritance. So kind of as a review, let's start by quickly developing the bank account class itself and go from there. We talked last time about the special init, the dunder, so-called dunder method because of the double underscore before and after the name, the init method that initializes an object. We talked about the self reference that is the first parameter for every method in a class. And in the case of a bank account, it accepts an account number for the bank account and possibly an initial balance, although if you leave that off, it can default to 0. And what an initializer often does is just set up the instance variables, in this case account number and balance, and often these are just storing the values that are passed in as provided when you create the bank account object. We'll see that in use in just a second. Sometimes the initializer is more interesting than that, as it was in the deck of cards class last week. But it's often just kind of this kind of storing the parameter value, the value that's passed in, into the instance variable, the guy that's preceded by self, which is what makes it an instance variable for the object. And keep in mind that every object has its own copy of the of the instance data, because of course every bank account needs its own account number and its own balance. So let's also create the dunder string method, and as we discussed, that his purpose in life is to return a string that describes this particular object. Now in the case of a bank account, we're going to return a formatted string that contains the account number and the balance, and the format that we will put it in, we will use this format method of the string class to give it some nice formatting. And in this case, we will put the account number in a field that works with a decimal value, followed by a colon, a space, a $sign, and then the other field will be where the balance goes, and that's a floating point value taken to 2 decimal places. So there's the formatted string. Here's the values that go into the formatted string, and that's what the string method returns for a regular bank account. And then the two kind of primary services that the bank account provides is a deposit method and a withdrawal method. So you deposit into a bank account a certain amount, and we keep things, this example keeps things pretty simple, and it doesn't do any checking on the amount. It simply adds it into the balance. So you're depositing into the balance, you're updating it. And in the case you define these methods however you choose, and in this case we're saying that the balance also returns then the updated balance. And we'll do the same with the withdraw method, self and an amount to withdraw. And in that case, we are taking it away from the balance. One more time. And then returning again the updated balance. So this is essentially, that's it for the bank account class. And that's pretty much exactly how the book presents it as well. So we have one bank account class that defines the concept of the bank account. You can set it up initially with an account number and a balance. You can, when you print it or concatenate it to a string, this is what you get back. That's what the string method does for you automatically. And then we defined whatever services we want a bank account to do. In this case, deposits and withdrawals. So before we go on to talk about inheritance, which is the primary discussion for the day, first of all, let's save this in BankAccount.py. And before we go on to the inheritance discussion, let's add a new one here that will just kind of be my main driver. I'll save this as main.py and make use of it. So I can say from bank account, the file I just wrote, the module I just created that has the bank account definition in it, I will import that definition, bank account. And once I have that, I can do something like this. Account 1 equals bank account. And again, what does the bank account initializer need? It needs a account ID, and that could just be any number. We won't get into the details of creating bank account IDs or anything like that, although in a real situation, obviously, that would be much more involved. And for our purposes now, I'm going to give this first bank account a initial balance of 200. And then I'll create another bank account. And I'll give this guy a little bit more initial money, $5,400. So this is the creation of bank account objects, right? Account 1 is a regular variable, and it refers to a bank account object. The bank account object that he's pointing to has a certain ID and a certain balance. Same thing then for account 2. One definition of a bank account, we wrote that once, the concept, the blueprint of a bank account. And now here we are creating as many bank accounts as we need with their own very particular data. So then I might do something like this. Account1.deposit. I'm going to deposit a value, let's say $100, into bank account 1. So the fact that I'm talking to bank account 1, I'm making a deposit and I'm passing in an amount of $100. We know from the code we just wrote, the self variable is the account I'm talking to, the particular bank account object I'm talking to, right? Each bank account has its own balance, for instance. And I'm taking that amount and adding it to that balance, that guy's balance. That's the whole point of the self reference. I got several questions about that in the past. Make sure that's a clear idea. So I deposit it into account 1. I might, for instance, withdraw from account 2. Let's take $2,000 away from account 2. So that one's, again, talking to the talking to this particular object and saying, do the withdraw method, do the withdraw service for this particular account and remove 2,000 from that guy's balance. Okay, that's kind of the whole idea behind the self-reference. And then I'm just going to print the two accounts. So what happens when you print an object? We talked about this last time. I'm going to print the account object, the particular object, and what it prints is what comes back from the string method. That's again why it's a special dunder method. You almost always want to define a string method so that when you print an object or when you concatenate an object to another string, what gets printed or concatenated is whatever gets returned by this particular function. Behind the scenes, the code for the print method, print function, is calling the string method of the account of the object I pass in this case account 1, and printing that. So let's see what happens when we run this guy, if we did everything correctly. There's the output. It printed account 1, which it prints the ID, the account number for that account, and its current balance. Its current balance is 300 because we started with a balance of 200 and then we deposited another $100, and so now the current balance of account 1 is 300. Likewise, when I printed account 2, I get his account number and a result of a current balance of $3,400. Started with $5,400, but then we withdrew 2,000. Okay, so that's objects. Here I am talking to a particular object, getting that object to do a service for me. One of the services it's providing based on the definition of the class, the object. This is the blueprint that all bank accounts are made from. Okay, so up till now, that has been essentially a review, hopefully, of the material we did last time. A different example, also from the book, but different than the one we had gone over in the video last time. So let's now add something more to that, to the concept of object-oriented programming that we hadn't talked about up till now. So I'm going to bring up a image that is straight from the book to kind of introduce this concept. The book has a nice discussion of an object-oriented concept called inheritance, and that's what we're going to explore now using the bank account example. So this is kind of two diagrams side by side of the concept of inheritance, two different examples. So suppose I had a class called mammal that represented a mammal in terms of any of the characteristics and services that I would want to define based on what it means to be a mammal. And I have a class that defines that. I could then extend the definition of that, derive the definition of a new class called dog from mammal. And here's the idea. If I have all the things that describe a mammal, and I need to describe a dog in particular, then why should I go through all the effort to kind of redefine all the things, because a dog is a mammal, so all the things that apply to dogs apply to mammals. Sorry, I said that backwards, actually. All the things that make an animal a mammal apply to dog, right? So the dog, the concept of inheritance is that the dog class inherits the methods and the data values stored in mammal. And then dog can then go on, the class dog can then go on and differentiate itself from any other mammals. Whatever makes, whatever else a dog is, it is a mammal. So it's all of those things. But it then also has things that make it different from other types of mammals, for instance. And those things go down in dog. So it's a form of reuse. I've already got this class mammal that helps me define animals that fall into that category. And now I want to define a particular type of animal that happens to be a mammal. So I inherit all of the characteristics of mammal and then put in the dog class anything that makes the dog unique within that mammal kind of category. Same principle, different example, same principle over here. We now have a bank account class that we just developed, and it can do bank account like things, fundamental things that apply to all bank accounts in our world, such as making deposits and withdrawals. All bank accounts in our world, you can make deposits and withdrawals, and we've defined what that means for a bank account. But let's say now I need the concept of a savings account, and the differentiation here is that a savings account, let's say, can earn interest. Right? No concept of interest up here in a bank account. Not all bank accounts earn interest. But a savings account, excuse me, a savings account, let's say, can earn interest. But a savings account is everything that a bank account is. It is a bank account, but it's also a bank account that earns interest. So instead of rewriting the deposit method and the withdrawal method, because a savings account could do that too, I'm just going to derive the savings account class from bank account, inherit all of those things, the ability, the fact that it has a balance and an account number, and the ability to do a deposit and withdrawal, get inherited into the savings account class, and then I go on in the savings account class to differentiate it from other bank accounts, in particular by adding the concept of interest and paying interest. Okay? The idea is once you have a class that defines a certain set of characteristics, if you need something that's close, then you can derive it and uh, capitalize on the fact that that definition already existed. Now, note that the book makes a big point of this. Note that this is forming what we refer to as an ISA relationship. When you're about to do something with inheritance, you want to make sure that the ISA relationship applies. You want to be able to say that the child class, and by the way, let's review those terms. The class that is used to derive the other class is called the parent class, or the super class, or the base class, and the class that is derived from such class is called the child class, or the derived class, or the subclass. All of those terms are kind of used interchangeably. And the relationship that's formed between them is an ISA relationship. A dog is a mammal. If you can't say that in English and make it make sense, then perhaps it's not a great inheritance situation. You want to be able to say that the child is a more specific version of the parent. A dog is a mammal. Not all mammals are dogs, but all dogs are mammals. Right? Same thing over here. A savings account is a bank account. A savings account is everything that a bank account is, plus some unique things that make it a savings account. But a savings account is a bank account. The child is a more specific version of the parent. Okay, so that's where we're going with the concept of inheritance. So let's see now how we do that in Python. So I'm going to create yet another file. I'll save this as SavingsAccount.py. and we'll write the savings account class here. Class savings account. It's a derived class. A child class is no different in terms of its definition than any other class that we've written, except that it has in the header this parenthetical in the class header itself, which is where you list the class from which it is created, from which it is derived. So this is all I need to do to say that savings account is derived from bank account. And even if I did nothing else, even if I just put a pass statement in here, then already this savings account is everything that a bank account is. It automatically inherits the characteristics and data of the bank account. It already inherits the ability to make deposits and withdrawals. It already has an account number and a balance. And I can prove that by simply out here in this main driver that we created, change the bank account to a savings account in both of the cases here, and change nothing else other than I got to import the definition of savings account so that I can create savings accounts instead of bank accounts. Now, so far, a savings account is nothing more than a bank account, right? But that should fly, except for I forgot to, over here, if I'm going to refer to bank account, I need to import the definition of that. So I'll import, or let's see, from bank account, import bank account. So I'm defining savings account in terms of bank account, which I now have the definition of, but I'm not doing anything unique to it yet. So it is essentially the same thing as a bank account. So let's see if this runs at this point. There you go. So now running it as having created two savings account, I get the exact same output because the savings account so far is exactly what a regular bank account is. But it serves no purpose to leave it at this, because if all you're doing is replicating what a bank account is, essentially all we've done is rename it. So instead of an empty class definition, now we're going to put the things in the savings account class that make it unique as a bank account, that go beyond what the bank account definition automatically gives us. So, for instance, we said that a savings account has interest. So let's define an interest rate value for the instance data for this account. And so I'm going to create yet another initializer. Now, what is the initializer of a savings account going to need to do? Well, we just said we're going to create a savings account that has an interest rate. So I'm going to put interest rate like so, and I'm going to give it a default value in case you don't want to pass it in of, let's say, an interest rate of 2%. And then I'll do self.interest rate equals interest rate. Okay, so if savings account now can accept an interest rate and store that value, and I can go on to use it in whatever methods I want to later. However, before we leave the initializer, let's realize that this is a bank account as well, and a bank account has an ID, an account number, and a balance, an initial balance. Let's go back to the main driver here. When we created a savings account, we passed in the account ID and the balance, the initial balance, just like we did when it was a bank account. In fact, we didn't even do anything with interest rate. We're using the default. Well, now we will be using the default version of the interest rate. But the point is, because it's a bank account as well, we still need that information. Note that over here in the driver, we don't have anything to do with bank account in here. The only relationship to bank account we have in this program is that savings account is derived from bank account, but the guy who wrote this program wouldn't even need to know that, right? He just needs to know I want a savings account. So I'm creating that, and that savings account needs an account number and a balance at least. So over here in savings account, we need to be accepting those values as well. So, first of all, I neglected my ubiquitous self reference as the first parameter. That's always needed. And let's now add, in addition to the interest rate, before the interest rate, I will add the account number and balance, which we will again default to 0 if you don't want to provide one. And so I'm going to, when I create a savings account, I will pass in at least the account number, maybe an initial balance, and maybe an interest rate. But what is storing? What is dealing with the account number and the balance? Nothing so far in this initializer. So, what could I do? Well, I could, and I'm going to take this out in just a second, but I could say self.account number equals account number, which is exactly what we did in the definition of bank account, right? We passed in the account number and we stored it. So I could do that here, but the point is, a better way to do this is to let the parent already do what the parent is good at doing. The bank account is already good at managing an account number and a balance. It already does things like deposit and withdrawal. So the kind of rule of thumb is, whenever possible, let the parent do the work that it's already good at doing. And it's already good at initializing an account number and a balance. Granted, it's not a big deal if I duplicated those lines of code here, but assume, for instance, that account number is a much more complicated thing to do, that we, instead of just passing it in, we're calculating an account number based on all the account numbers that have come before and maybe some algorithm that generates the account number, right? In a real situation, just assigning an account number might be a much more complicated process. So I don't want to duplicate all that effort here. I'm going to let the bank account, which already handles that, do it for me. So how do we do that? Let's take that line back out, and let's bring into the discussion the super function. The super function, super as in super class, refers to the parent of the class I'm in right now. So in this case, the super reference refers to the bank account class. And so once I'm referring to that, excuse me, I can call whatever methods I want to from the parent. So in this case, I'm going to call the init function from within the init of savings account. I'm going to call the init function of the bank account using the super reference and pass in account number and balance. So I pass in the account number and balance to set up my savings account, and then this guy immediately hands those off to the bank account class to set that up, because it's already good at setting that up. It already does that, right? By the way, instead of the super reference, the super function call here, I could have said bank account directly, but it's usually good to make use of that super function call. Okay. What else am I going to do in my savings account class? Well, I'm going to also define the string function again, because I've inherited the string function just like I inherited the init function, but I'm not going to be satisfied with what the string function of the bank account does for me down here in savings account. So I'm going to create a string function myself, and I'm going to create a description and return it. But what should that description be? Well, once again, I'm going to make use of the super function, and I'm going to say that the description that I'm going to pass back is equal to at least start with um, the string I get back from the call to the parents version of the string function, and start it with that. So this guy's calling the bank accounts version of string, which, as we saw, returns what? A string that contains the account number, followed by a colon, followed by a $sign, followed by the balance. So that is already done for me. But what it doesn't take into account is the whole interest rate thing. So I'm going to tack on to that description, concatenate to it another formatted string that includes the interest rate, and I'll make it a percentage, so I'll multiply it by 100. And again, we can get into the details of how this is formatting, but I'm just going to do a parenthetical and say that just to add a note, basically, that's saying that this guy earns, let's see, I'll do it to one decimal point. I'll add the percent sign, and say that adds that much interest, that account earns that much interest, add the parentheses. All right, we'll see this in action here in just a second. But again, and by the way, this is called overloading when I'm overriding. When I define the init function here and the string function here in savings account, what I'm saying is I've inherited from bank account the init function and the string function, but I'm going to override the definition that I've inherited from bank account with my own version. You're basically saying, thank you, parent, for that method, but it's not quite sufficient, so I'm going to override the definition with my own, and in both of these cases, we're making use of the parent's version and then doing something more with it, right? Okay. What else are we going to put in savings account? Well, again, we've defined the concept of the interest rate, but we haven't done anything with it. So let's just add a simple function that adds interest to the account whenever we call it. And again, it needs the self-reference. And what's this guy going to do? Let's calculate what the interest is. So, and we'll just keep it simple. We'll say that the current balance we have, times the interest rate is the amount of interest that I'm going to add into the balance. And I could update balance directly here, but what I'm going to do is call deposit, kind of just to show that we can, right? We can call the deposit method, and I'm going to deposit the interest into the account, and then again return the updated balance. So let's think this through for a second. I'm going to clear what I've done down here and shrink this down a little bit. So here's the definition of savings account, and I'm doing things like calling the deposit method and referring to the balance. But those things aren't defined in here anywhere. those are defined in bank account, but they're part of this object, this class, because of inheritance. I derived bank account, I derived savings account from bank account, and so it automatically got a deposit method, as if I had typed the deposit method right here in the definition. It also has the concept of a balance and an account number and all the stuff that a bank account already has. So I think we'll leave the definition of savings account just like this, and it's much more. It's so much more than what's just listed here in this definition, simply because of inheritance. A savings account is everything that a bank account is, plus these overridden versions of init and string, and this new method that we added that had nothing to do with regular bank accounts, but is very much an important part of being a savings account. All right, so there's the definition of our savings account class. So let's go back to our main driver, which we already changed to deal with savings accounts, and we're doing deposits and withdrawals, and we know we can do that because a savings account is everything that a bank account is. But let's now update this a little bit so that it plays around with the interest. For instance, when I create this first one, let's give it a different interest rate. Let's give it 0.15, right? 1.5% interest. And if you remember, the interest rate could be defaulted, so we'll leave it off of the second one, and it defaults to an interest rate of 2%. Okay? So I'll leave the deposits and withdrawals in there. But now let's do this. Account 1 dot add interest. Right? The account is a savings account, and therefore it has an add interest method, because all savings accounts have add interest. Savings accounts are derived from bank accounts, so they already had a deposit and withdrawal. Now they also have an add interest. So I'll do account 1 and account 2 dot add interest to make those happen. So when I print out the accounts, what am I going to do? I'm going to see the result of the string method, but the string method of the savings account, right? Which is now calling the bank accounts version of string and then adding on that that information about the interest rate for that account. So let's see what happens when we run this now. All right. So there's my information as it is defined by the bank account class, account number : current balance, which is slightly different than the amount we had before because we've already added interest to that account. And the note here is that this account earns 1.5% interest. Same thing with account 2. We had already added interest, so it gives me the string version as defined by bank account, slightly different balance. This guy earns a 2% interest rate, right? So I think we'll leave it there. The idea that a savings account is derived from bank account gives us everything that the bank account has, plus whatever we decide to add that help it define itself as a savings account. All right, we'll leave it there, and see you next time. Thanks.